Hello, hello. So we're going to introduce another rule for derivatives. This is going to be the first day with it. So we're going to start off nice and slow with the chain rule. And so get yourself ready for notes and we're going to get started. Now, the chain rule is for composed functions. So it's something where you have one function inside of another, sort of like the examples we see here. For the example number 1, this is the same as d dt of sine with t squared on the inside like this. So if I'm looking at the composed functions here, sine is f, and then t squared is g. Now, what we're looking at for the derivative of a composed function like this is that it's f prime of g. So you take the derivative of the outside. So it's, let's see, dx of f, kind of the way it is with g still inside, and then multiply it by the derivative of the inside function. So I'll often use this notation where I call this is the outer and then the inner as a way to differentiate it, like this. So then, if we're looking at our first example, we have f is equal to sine, and g is equal to t squared. Now, f prime would be cosine. We did this in our last lesson. And g prime is 2t. And so what we're going to do is we're going to take our outer f prime, plug in g. So that's f prime g, and then times g prime. So the derivative here would be cosine of t squared. So you'll notice here, we still have the same t squared. Here we're just changing sine, cosine, just like you'd expect. And then multiply it by the derivative of t squared right here, which is 2t. And that would be the derivative of sine of t squared. Now, I use this as an example, and now we're going to look at how it's slightly different when sine is the thing that's being squared. So what we've done here is we've changed the inner and outer functions. So this is the same as the derivative of sine of t squared, where now the sine is our inside function and the squared is our outer. So that means that this is f and the inside one is g. So we've switched around the position. So f is equal to squaring. And so then f prime is 2 times x to the first, or just 2x. G is now our inner function, so sine of t. G prime is cosine t. So when we do this, we take our function and we plug in g. So we end up with 2 times sine of t times the derivative of that inner one, which is cosine of t. So here, if you can imagine, the squared comes down, minus 1. So that's how you get 2 sine of t, and then multiply by cosine of t. Now this is just a lovely way to write it, but you might remember some of your trig formulas from last year. 2 times sine of t times cosine of t is the same as sine of 2t, another composed function, by the way, like this. Now let's look at one more example using roots that we see here. So again, I think it's helpful to rewrite it slightly so that I end up with x squared minus 4 to the power of 1/2, like so. And that's just, one writing like this means that we can use it as a power rule, and it's easy to identify inner and outer. So this is my inside function, so that's g, is x squared minus 4, and then to the power of 1/2 would be the outer. Now you can keep writing out the table like this, but sometimes it might be easier to just say, okay, well, I'm going to follow the power rule in this case, bring it down, -1. So my first step for f prime of g would be 1/2 x squared minus 4 to the -1/2. And then I need to multiply by this derivative, which in this case would be 2x for the x squared minus 0 for the 4. And so I end up with 1/2 times x squared minus 4 to the -1/2 times 2x. So this is our unsimplified version. One thing that's important to be able to do is simplify these, especially because in the back of the book that will always show you the simplified version. So with our constants, we have 1/2 times 2, which cancels out. Then I will end up with x I might write up front, and I'm going to take that negative exponent and turn it into a fraction. So x squared minus 4 to the +1/2, which would be x times 1 over root x squared minus 4, which can be finally written as x over root x squared minus 4. So there's definitely times where leaving it in the unsimplified version is fine, but you want to be able to simplify it as well. If you have questions about any of our new rules for derivatives, please let me know, set up a Zoom meeting, and I am here to help you and answer any questions that you have.